Okay, so let's see. What is the quantity that's represented? The shaded area, ABC. That's this area right there, right? Okay. Remember that the area under is equal to displacement. Okay. Notice that they're making the downward velocity positive. That's okay. They wrote the test. They can do that. So these areas really are, I believe, negative displacement, right? Okay. So part of this graph is the thing accelerating, right? At 9.81 meters per second squared. And part of the graph is it accelerating up at, and of course the slopes of these are the accelerations, right? Accelerating up at something big, right? Big. Some big acceleration that you calculated in the previous part, right? Okay, so first figure that out, right? Okay, so anyway, that's what you're going to talk about here, right? Say what it is and what's represented, right? And then the second part says air is introduced into the tower, right? Okay, so notice this is the part where it's of course accelerating down. And this is a perfectly straight line because there's no air friction, right? So two things are going to happen when you introduce air, right? It's not going to go as fast, not hit as fast, right? And it's not hit as fast, and it's going to hit later. And I believe I got this wrong when we did this like together with the kids. I missed this second thing, right? Of course, if it's not going as fast, it's going to hit at a later time. Okay, so it's not going to be as high, and it's going to hit at a little bit later time. So decide, just arbitrarily where you think it is, and then decide what shape, right? The shape is important of that graph, right? At low speeds, is air friction super important? At higher speeds, does the air friction become more important, maybe? Right? Yeah. And then, of course, once it hits the foam, it's going to slow down real fast. So, yeah, hope that helps.